As Thomas said, my name is Lars Chresten Lund Hansen from the Arctic Research Center in Aarhus University, where we had the luck to join this expedition on the Lomrock, the Oden, the Swedish icebreaker to the North Pole in 2012. So this was not a real FACEIT program, a study program by FACEIT, but I was asked to have a presentation today as Michael couldn't do it, so I thought this might be a good story to tell you about the results that we got from up there, a little bit far away outside the FACEIT area, but anyway, the North Pole is a very interesting place to look. So we joined this expedition, international expedition, and this was a Danish-Swedish expedition to the North Pole mapping the seabed, because at that time there were no real or established boundaries inside or around the North Pole. How can we extend, we were there on behalf of Greenland, the Danish kingdom as it is called. How long can we extend the border, so to speak, of Greenland out into the Arctic Ocean? How long out can US and Canada and the Russian and the Norwegian? It was not decided yet, but that has been then based on all the mapping, and now they are working on finding out the boundaries, because it's oil, gas, natural resources, any kind of elements, rare earth elements are already been taken out from the Arctic Ocean. So there's lots of economical interests in the Arctic Ocean. But the title of my project, or this talk, is there has been a lot of discussions what will happen when the ice disappears. We have seen this graph of the summarized extent has been decreasing over the decades, and it can be calculated that in 2050 or something there will be no more summer ice. There's lots of ice during winter still, but in summer there will be less and less ice. So what will happen in the Arctic Ocean, in the Amundsen Basin specifically, when we have this So yeah, we have seen that this decrease in the Arctic sea ice extent in summer dramatically, and the research question is then, what will happen to the Arctic Ocean primary production, as also Tobias told about. Primary production, we need some light, we need some nutrients to do the photosynthesis. And who is doing the photosynthesis? These are the algae, the phytoplankton living below the sea ice in the water column. They are also in the sea ice, that's shown by Kai. There's a little bit, the production is estimated to be around 5 to 10 milligram carbon per square meter per day below the ice at the moment in summertime. But what will happen when we go from a situation with the sea ice with a high albedo to a situation like this? We have no sea ice any longer. The albedo is 0.1 compared to 0.8 or something, which means that much of the light, much of the heat is reflected back to the atmosphere, back to space. We will then have this situation over here. What will happen to the primary production? There will be more light, there will be more wind, we will have mixing of the water column, that we don't have that much in the first situation. So what will be the primary production in the central Arctic Ocean? Research has shown that we have to go a step back and take a look at the Arctic Ocean. The Arctic Ocean is surrounded by land compared to Antarctica, which is surrounded by oceans and water, surrounded by land, and we have the shelf, huge shelf areas here in the Canadian and in the American and in the Russian side, and then we have the deeper basins here. And it has been shown that the primary production has been increasing, especially in the shelf areas. They've become more and more. There's less and less ice cover in summer. This is 2012, where we have the minimum ice cover. The purple line here shows the average median for 20 years. So 2012 was real low. But you can see it's in the shelf areas where we have less and less of it. The sea ice cover is very, very low. And primary production has been increasing due to less and less sea ice in summertime on the shelves. Question was, our question was, what will happen with the primary production in the central Arctic Ocean, which is the last spot where we will have sea ice. And these are the stations that we visited, either by, from the icebreaker and flying also with helicopter during our research there. The Arctic Ocean, if we look at what we call the hydrology of the Arctic Ocean, there's a lot of fresh water coming into the Arctic Ocean from the Russian rivers. These blue lines shows the pathways of this fresh water coming from the Russian rivers. And if we look at a CTD profile, we look at the salinity measured here in the Central Arctic Ocean, we see there's a surface layer here of comparatively low salinity, related to the freshwater inflow from the Russian rivers, but also from melting of the ice. The ice is nearly freshwater. Not much salt in this ice. So due to this freshwater inflow and melting of the ice, we have this surface layer of freshwater, which you don't see that if you compare that to the temperature. It's cold in the top and then it gets warmer. And then this one, this is only down to 200 meters. We have measurements to 500 meters, 34, 35. It reaches into the Atlantic water that you can't see it here, but there's an arrow. The red one shows the Atlantic water flowing into the bottom of the Arctic Ocean. So if you go into and look at a detailed profile, just one profile from the Arctic Ocean, representative of what we saw up there, is that the blue line here is salinity, right? And the green line here is fluorescence. The fluorescence is a measure of biomass, as Tobias also. So the biomass of the chlorophyll. The red one here is a nitrate. And what you can see, the blue line I marked here is where the water column is stratified, as we call it. We have the freshwater influence layer on top. We have the salt water layer at the bottom. And there's the mixing between these two layers is very, very low. So there's no mixing, there's no transport of nutrients across this interface. It's a very strong interface. As you can also see from looking at the nitrate, there's not much nitrate. It's taken up by the phytoplankton in the surface layer. And then below the surface layer, below the stratified stratification, it starts to increase. So there's no transport of, very, very little transport of nutrient-rich waters into the upper layer due to this stratification, due to the freshwater layer. So no nutrients are entering into the surface layer. And this is the situation. This is measured below the sea ice. And if you look at the concentrations of the chlorophyll, 0.4, 0.32, it's very low concentrations. We measured, or we developed this index of stratification also. If we look at the potential of, just look at the density of the water column. This is the difference in water column density between 10 meter and 60 meter, compared to the differences in nitrate, also 60 and to 10 and 60 meters. That's a nice correlation. So the stronger the stratification, the density is the density of the water. The stronger the stratification, the stronger the difference in nutrient concentration, or nitrate concentration between surface and bottom water, right? Which shows that this is driven by this stratification of the water. So yes, this is the situation. Light is very low too. The black one here, there's much, much less, right? The scale is also 10 micromoles. This is below the ice. So what can we do to, or what we did to figure out what will happen with this system when we remove the ice? So if we don't want to wait until 2050 or something, we want to have the answer right now. We made a model. We developed a model. In the model, we took away the ice to see what happens with the primary production. And this model is based on, it's a biogeochemical model driven by salinity and temperature and water, air and atmospheric forces. These are the parameters driving the model. We took away the ice, and then we looked at the chlorophyll concentration, and we also looked at the primary production. The primary production also included grazing by zooplankton, sinking, etc., all the parameters that we normally take into account looking at primary production. So in this model, we had, this is two months, July and August. We used real data. You can see the temperature is decreasing. There's some wind, not much wind, but there's some wind a little bit. And the light at the surface was also decreasing. And here on the first day of July, the ice was moved, and what you can see, the colors here, you can see the temperature is increasing of the water, getting warmer because of the heating. And this is the chlorophyll. There is a little bit of bloom here. These lines here shows the nitrate. There's some blooming in the beginning, and you can also relate wind events. We have some wind events up here that this actually increases the chlorophyll concentration, showing the primary production, which is also shown down here. Over time, and if you integrate the signal, the trick is that if you integrate the whole signal and calculate, we saw that, or we measured with the ice 4 milligrams per square meter per cubic meter. We have one month is 37, and then we have the 2 months is 55 milligrams per square meter per day. Very low numbers for those who are working with primary production. In Nukefjord, where we already saw 500 to 1,000 milligrams per square meter per cubic meter per day. So these numbers are extremely low, even though the relative increase is fairly high, 10 to 50, 30 times higher, but the values are still very low. And the reason for this is that if you look at the salinity, for instance, these isohalines shows the salinity. Stratification is still maintained. Stratification is still maintained even though we had some wind events. Normally with the wind that would mix the water column, we would have some, we would decrease the stratification, but the stratification is so strong that even though we remove the ice, we expose it totally to the wind is too weak to break down this stratification, which is the reason that we don't have, still don't have any transport of nitrate. We've seen high nitrate concentrations in the lower part of the water column, still low in the top of the water. So in the central Arctic Ocean, it seems, according to our model results, that we will go from this situation here, and then it will increase to 35 to 50 milligrams per square meter per day, so it's not that much. There will be an increase, as I said, or there is an increase in the surrounding, in the shelf areas. Also, it has been mentioned that due to climate change, there will be increased rates of precipitation, because it's already this morning, and which will, of course, give a lot of discharges from the Russian rivers, which will, what has been supposed to increase the production in the central Arctic Ocean, or in the Arctic Ocean at least, but it will probably not affect the central Arctic Ocean because the nutrients they are already utilized, taken up by the phytoplankton before they even reach the central Arctic Ocean. So it seems that this is the situation that we will have in the future when we reach more or less ice-free central Arctic Ocean. It's also important to point out that even ice-free, it would be probably ice-free for 1 or 2 months in summer, but there will still be a lot of ice. This is 2012 also. In March, where we have maximum shares extent, even areas where there's more ice than the medium. So there's, I mean, sometimes depressing to see on the news there's no ice anymore, and how about the polar bears, and everything is so sad. But there's still, I mean, there's a lot of sea ice in the winter time. So not that we should not worry about that, but I mean, lots of sea ice still. And it's an ecosystem, as mentioned by Kai. which is important to keep in mind. Oh yeah, and the last slide, there's still some ice.
Thank you, Lars. Any questions? I know that the microphone cube is somewhere in rotation already.
Just a quick question. When you take away the ice, wouldn't the stratification and the wind patterns change completely? So that, the situation.
That's a good question. We did not anticipate that there would be any changes in the wind pattern, but yeah, we use the wind pattern that we have today. But you can see 5 to 10 meters per second, and it's a permanent high pressure covering the central Arctic Ocean. So yeah, not that much wind, but good question. Good one, yeah.
Good. We have another question over here.
I'm curious about like pelagic phytoplankton versus the sea ice phytoplankton. So if in 2050 there's no multi-year sea ice at all anymore in the summer, would that mean that those phytoplankton that depend on sea ice would go extinct? Or can they live in the water column, or are they totally dependent on the ice?
Well, good question. No, they are totally dependent on the ice. It's a species that has specifically adapted to living in the ice. Specific species. So they will disappear over time, yeah.
One more question? Yeah?
Good.
This study was conducted in summer?
Yes, it was in summer, in August.
Yeah, because the point is, I wonder if you look at the same nutrient profiles a bit earlier, maybe they could be different, because I wonder if nitrate was already used before you started to sample.
Yeah.
And I'm asking this because in the Amundsen Basin, for example, under the ice, in winter, we found profiles in 2015 where you could see that there was mixing before, and nitrate was relatively high at the surface.
Yeah.
But we also found profiles like those you showed, even in winter, with apparent depletion, and this suggests that there was no mixing at the right point. So you can have mixing sometimes you may not have mixing. So my question is, what do you think about this? Could you have less limitation if you went there a bit earlier and get a different perception about the primary production?
I guess my guess is that we have a high primary production at a time in early spring below the sea ice, and then at that time the nutrients that they are utilized, and then later on you have this very where you still have regenerated nutrients moving around. So I guess there is a bloom in springtime at a point, and then it's completely depleted.
Thank you.
Thank you much.
Yep.
Thank you, Lars.
Yes, you're welcome.